For our next lesson, we're going to tackle something that you should be familiar with from your later elementary school or middle school, and that's the order of operations. It can seem really straightforward, and when you're just dealing with order of operations, it actually is pretty straightforward when that's the only aspect of a problem that you need to think about. The order of operations comes up all the time when we're dealing with variables, and sometimes when we're dealing with variables and we're dealing with parentheses and we're dealing with negative numbers, which are all coming up, it can get a little bit complicated. So it's really worth it to take the time to emphasize the order of operations now and get in the habit of thinking through that order. In fact, when we go to solve equations, we reverse the order of operations. And so it's kind of like you do something and then you undo it. So the more you're familiar with the order that you did it, the easier it is to turn around. It's kind of like putting on your socks and then your shoes. So when you want to undo it, you take off your shoes first and then your socks. Nobody tries to take off their socks while their shoes are still on. So something that you might be familiar with from a previous class is what we call PEMDAS, or Please Excuse My Dear Aunt Sally. Okay, so I'm going to put that up there and kind of give you the summary of your order of operations. Now, notice when I wrote that, I have the P, the E, then I have the M and the D, and I kind of have those grouped together. And then I have the A and the S, and they're grouped together. And the reason they're grouped together is because they actually have the same rank. So it's not like you do multiplication and then you do division. You would actually do them at the same time from left to right through your problem. So I'm going to put like a little L2R. And the same with addition and subtraction. They have the same rank in the order of operations, but when we list them, we need to list something first. So we list the addition first, but they go from left to right. So you don't go and do all your addition first and then do your subtraction. Like if that's all you have in the problem, you work from left to right. And that can be a really common misconception that people have. Now, the P technically stands for parentheses. So I'll go ahead and put that in there. Parentheses. But really what it stands for is grouping symbols. Okay, so we want to make sure that we're really clear about that. Parentheses are really, it's in the acronym as a P for parentheses, but it's really any kind of grouping symbol. And there are lots of grouping symbols that sneak in. Just parentheses are the ones that we think of at first. That of course you got parentheses and then you have brackets and stuff. That you also might have a symbol called absolute value, which is an operator, which can group things. You can have a square root, and I believe like you first cover square roots in middle school. So like that symbol functions as a grouping symbol. You can have fraction bars that function as a grouping symbol. So anything that like kind of groups a chunk of things together, you need to like look inside that group and kind of simplify everything in that group before you deal with stuff outside that group. The E stands for any exponents. And then I already mentioned M and D are multiplication, division, and A and S are addition and subtraction. And they go from left to right. You might have heard in my Algebra 1 teacher, I tell my students this all the time, my Algebra 1 teacher did not let us write subtraction. So once we covered negative numbers, we had to write all of our subtraction as adding a negative. And when you think of it that way, that any of your subtraction can be written as addition, it makes more sense that you would just go from left to right. So what I'm pretty much going to do at this point is work through several examples just so you can see how these problems are worked out. And then you need to practice. You just need to practice thinking your way through the problems and working on that nice top-down structure. So the first one that we'll look at is 3 times 4 squared plus 1. And this is one that a lot of my Algebra 2 students actually mess up because they see that multiplication right off the bat and they're like, oh, 3 times 4, that's 12. Except that that's not the order of operations. In your order of operations, you have... there we got our order of operations there. the exponent comes before the multiplication. The only thing that is being squared there is the 4. The 3 is not being squared. So if you multiply it first, it's like you're saying, oh, well, like we'll just like square the 3 along with it, which isn't what's happening in that problem. And so the first thing we would do there is we would do the squaring of the 4, and now we would do multiplication because we have multiplication and addition. So we would do the multiplication to get 48, and then last of all we do 49. Make sure, I'm saying this in every lesson, that you want to work top to bottom, top to bottom, top to bottom. Okay, and you should just carry out one or at most like 2 operations at a time. Next one. We'll look at, I might put a couple on the screen here. So we'll do 3 times 4 all squared plus 1. And then we'll do a couple more. 3, this is actually a good bank of problems here. And the last one, oh gosh, this is fun. Okay, maybe fun is the wrong word, but I'll stop. All right, so what we have going on here is pretty much we have a 3, a 4, a 2, and a 1. And they just arrange them differently. So we're just kind of putting those parentheses in different places. And I really like this because it shows the importance of the placement of the parentheses. So remember, in our order of operations, we start with grouping symbols first. So in this first one on the left-hand side, we have a grouping symbol there, and we have 3 times 4. Now notice when I said it out loud, I did say 3 times 4 all squared, and that was a verbal way of indicating that we have parentheses there. But we'll start with 3 times 4, which is 12. And then once you do that, you don't need the parentheses. Like you could put the parentheses around the 12, but that's the only thing in there. Like what are we trying to group exactly? So that becomes 12 squared. 12 squared is 144, and 144 plus 1 is 145. Now, the next one just kind of shifts those parentheses a little bit so that the parentheses are around the 4 squared plus 1 instead of like the 3 times 4. So we're going to start in the parentheses. Inside the parentheses, we actually have multiple things going on. Inside the parentheses, we have an exponent and we have adding. And we know that exponents come before adding. So for this one, the very first thing we're going to do is we're going to square the 14. And that would be true even if they were out of order, like in the other order, because exponents would come first. Then we'll do 16 plus 1, which is 17. And you can retain the parentheses there because you have the multiplication, or if you prefer to write the multiplication differently, you can write the multiplication like that. But you can't write just 317. And then we'll do 3 times 17, which is 51. So it absolutely matters where those parentheses are. In the last one, they grouped the exponent together. So we will start with the parentheses, and the parentheses in this one are, sorry about that, I kind of messed that up. There we go. 2 plus 1. So we'll have 3 times 4 to the third. 2 plus 1 is 3. Now we have to do the exponent. So don't fall into the trap of multiplying first. You have to do the exponent first. 4 to the third power is 64. I don't know if you can hear that, but I have cats running around on the top of my kitchen cabinets and howling, so you might hear them. All right. And I think that was a pretty good bank of problems. Now let's talk a little bit more about this like left to right stuff. So if you have like 24 minus 8 minus 6, okay, that is strictly subtraction. And so we're going to go from left to right. So you're not going to do like 8 minus 6 is 2 and then do 24 minus 2. It's going in the wrong direction. So if you have all multiplication, you're going to go from left to right. So some people will kind of picture that as there's like parentheses around it. And sometimes like we'll do that. We'll add parentheses in. I call them cosmetic. If you think about cosmetics and makeup, like makeup changes like the way your eyes look, but not what they do or how they work. And so cosmetic parentheses change how a problem looks, but it doesn't actually change the order of operations or anything. So sometimes people will put the parentheses in to draw your attention. to a specific aspect, just like a woman might wear eyeliner or something to draw attention. So we'll start this one by doing 24 minus 8, which is 16, and then 16 minus 6, which is 10. Next one, we'll do 15 minus 2 plus 8. So a lot of people will get this one wrong because in the order of operations, we often say adding before subtracting, but that's not how that works. Adding and subtracting go left to right. So if you try to add them first and you do like 2 plus 8, then you'd have 15 minus 10, which is 5, and you would have the wrong answer. So we're going to do 15 minus 2 first, which is 13. And then 13 plus 8 is 21. Now, I have had some students say, well, it's a negative 2. So you do like negative 2 plus 8, which is 6. And then 15 plus 6 is 21. That's actually fine. If what I just said was super confusing, pretend I didn't say it. Okay, just like kind of carry on. And then let's look at one more. We'll do 16 divided by 4 divided by 2 minus 3. All right, so we've got this division going on here. Okay, I had to look at that again. I actually copied it wrong. I was like, what on earth is going on? This is actually a plus sign. So there we go. I'm like, what is, I'm looking at a problem done out. I was like, what am I looking at? It was a plus sign. So now that makes a whole lot more sense. So looking at this one, we do have the division. So division comes before either adding or subtracting. So again, sometimes you'll see people do this. Okay, it's not necessary. We understand that the division would happen first, but it is it's cosmetic. It changes how it looks and it draws your attention to a specific part of the problem, and there's nothing wrong with that. 4 divided by 2 is 2, and now we go from left to right across this. So 16 plus 2 is 18, and 18 minus 8 is 10. Oh my gosh, I'm on a roll. I don't know why I copied it as an 8. I can just change my problem. 18 minus 3 is 15. Okay. It's what you get when you get a free video, okay? And you get somebody who's worked all day and then is trying to put this together like after working all day. My apologies. It's a 3, not an 8. Anyway, okay, I think that summarizes just about everything that you need to know, and it's really just an issue of practicing from this point on. You just have to work through some problems and practice, and even if you understand it conceptually, you just want to rehearse and rehearse and rehearse so that the order that you're doing it, you don't even have to think about the order that you're doing it. Also, as I keep saying, pay attention to that structure. You want that top-down structure. Don't revert to a calculator. Really work on that. It will pay big, big dividends later. So I'm going to go ahead and put several practice problems on the next slide, and then we will talk about them. Okay, so here are 7 problems to practice on. The first one reads 10 times, and that multiplication symbol right here is not necessary. It's not wrong, just the implied operation there would be multiplication, times 3 plus 1 minus 5. Second one is 8 times 3 all over. And again, notice like the phrasing there, like all over. 4 plus 3 squared minus 1. The next one is 8 divided by 4 times 6. So I don't know why I reverted to like that times symbol. I should probably be consistent. Next one is 2x plus y over 7 when x equals 12 and y is equal to 11. So we want to remember like our algebraic expressions and what it is to substitute. X squared plus 2x plus 1 if x is equal to 5. 3x squared if x is equal to 2, and parentheses 4 minus 2 all squared plus 5 all over 3. So pause the video, take some time, work it out, see how you do, and then unpause it, and we'll go over them together. Okay. So for this first one, what I'm going to do is work them out on the side and then erase them. So pause the video as needed. So for this first one, Remember, we start with our grouping symbols. And so we're going to start with the 3 plus 1, which is 4. And then we have multiplication and subtraction. Multiplication comes first, and then we subtract. So we get 35 as the answer. And as you're checking that, I know I say this every video, but as you're checking that, you want to look at your work. Make sure your work does not have numbers floating off to the side. Make sure that you're not working left to right. You want to work top down, top down, top down. There are very few places in math where it's common for us to work left to right. There are a few, but okay. So for this one, we actually have a grouping symbol, and that's the fraction bar. So the fraction bar does function as a grouping symbol, and it groups the 8 times 3 together, and it groups all of that together. And what that means is that you're going to simplify the top and you're going to simplify the bottom before you do anything with the top and the bottom. So before you do any division or you do any trying to simplify the fraction or anything, you've got to simplify everything in the numerator and denominator. So sometimes students will be like, oh, I'll like cancel out the 3's. No, that's out of the order of operations. It's one of those sneaky things. I'll tell you where students do it a lot. They'll have like an x squared, like something like that, which we haven't gotten to yet, but they'll try to cancel the x squareds, and you can't cancel the x squareds because of order of operations. So the better you know your operations now, the less likely you will be to make a mistake like that later. So we have to simplify the 8 times 3, and then we have to simplify that mess down there. Well, 8 times 3 simplifies to 24. Now in the denominator, we have adding, we have an exponent, and we have subtracting. And order of operations says we do that exponent first. And now we're not done yet. We have to go from left to right because we have adding and subtracting. Those are going to go from left to right. So 4 plus 9. Now notice what I'm doing here with the 24. Like even though I'm done with that part, I still copy it down, and it does not take me a long time or anything. So 24, bring that down. 4 plus 9 is 13. 13. I just got a notification over my palette here. There we go. 13 minus 1 is 12. And now that we've simplified everything we can simplify, now we can go ahead and do the division. 24 divided by 12 is 2. So notice how you did on that. And again, make corrections to your structure, even if you've got the 2. Okay, even if you have the 2, that's great, wonderful that you have the 2, but you also want to have it written in a nice way. You just kind of have to trust somebody who's been doing this for a really long time that will pay off for you. Next one is 8 divided by 4 times 6. And this is just a straight up, like, is somebody going to trick you into doing the multiplication first and trying to do 4 times 6? Nope. Like the left to right. So we're going to do 8 divided by 4, which is 2. And then 2 times 6 is 12. Next one is an algebraic expression. So we are plugging in stuff. So for the next one, we have 2x plus y over 7, and we're going to plug in 12 for the x and 11 for the y. And 7 denominator. And I know I mentioned in a previous lesson that sometimes I'll have students that they'll kind of make up their own notation for multiplication. They'll just try to put in like the 2 and then the 12 next to it, and they'll try to do something. And I actually saw that today while grading some homework where a student wanted to do 2 times 5 and they wrote it as an exponent instead. Because they weren't using the proper notation. So do be careful of that. Now here again we have the fraction bar, and the fraction bar is acting like a grouping symbol that tells us you've got to do everything with the numerator first. So in the numerator we have multiplication and we have addition. We have to do the multiplication first. So 2 times 12 is 24. And we're not done yet. We have to do 24 plus 11, which is 35. And only once you've done everything you can do, then you can kind of mingle the numerator and the denominator. Later on in math, I shouldn't have done that. We talk about simplifying algebraic expressions that way. Okay, so that was that one. So you should have a 5. Next one down is, this is a special kind of expression called a quadratic. And in Algebra 1, you get to quadratics a little bit later on. In Algebra 2, you hit them early because it's assumed you've seen them before. So we're going to take x squared plus 2x plus 1 if x is equal to 5. So we'll go ahead and put in a 5. And again, remember you need to indicate the multiplication. You can use either the parentheses or a dot. Would be fine. And now we've got a bunch of operations. So we have exponents, we have adding, we have multiplication, and then we have some more adding. Order of operations says that we need to do the exponent first. So that's 5 squared, which is 5 times 5 or 25. Now, some people would have you copy down like 2 times 5, but realistically, like now that you've done the exponent, you're free to go ahead and do the multiplication too. You don't have to copy that down again. And then 25 plus 10 is 35, and 35 plus 1 is 36. Next one is 3x squared. So this one is one of those that's intended to trick you a little bit. For x is equal to 2, so I am going to go ahead and plug in the 2 like so. And again, watch that order of operations. You do not multiply first. Exponents have to come first. So this has to be 3 times 4 because 2 squared is 4. And your answer should be 12. If you try to multiply first, you'll get 3 times 2, which is 6. And then 6 squared is 36. Not the same answer. And they can't both be right. And then the last one is 4 minus 2 all squared plus 5 all over 3. And so we've got 2 grouping symbols. We've got the grouping symbol of the fraction bar, and then we have the grouping symbol of the parenthesis. So we're going to simplify this whole chunk first. And we have the subtraction, we have the grouping symbol, we have the exponent, we have the adding. So we're going to start inside that grouping symbol to get the 2. 4 minus 2 is 2. And now in my numerator, I have 2 squared plus 5. So 2 squared is 4. And now finally I get to the addition. 4 plus 5 is 9. And then very last of all, 9 divided by 3 is 3. So hopefully that went pretty well. Always reach out, to your teacher if you have questions or you got something wrong and you don't understand it. And that completes our lesson on order of operations.